I will start by showing the part of the network that relates to coin prices and how we find arbitrage cycles and how we handle them. And to start, we receive coin prices or exchange rates between a currency pair from the API at GroupÄØÅ. We then send this to a city application called Arbitrage app, which gets received by the stream exchange price input stream. And these prices gets forwarded to GroupÄØÅ price stream. We send this exchange rate to the arbitrage cycle EP, and that looks like this. So here we receive an exchange rate. We pass it along to a task called find arbitrage cycles, which is uses a Java delegate that looks like this. And here we contain some static maps and lists of the continuous exchange rates and currencies that we receive. And we use an algorithm that I won't get into detail with. And that outputs some cycles, possibly, and we append this value to the execution for each cycle that we find. It gets sent here in the send cycle event task using an HTTP connector, and it is then received by city again. And we filter the cycles that are too long and have a too low gain rate, which means that we won't make as much profit of it. The cycles that we deem valid are being sent back to city to a process called handle arbitrage opportunity, and it looks like this. So over here we receive a message called arbitrage cycle, and our first task is to determine whether the cycle is new. So if we have already entered the rest of the process for a similar cycle, we just choose to ignore it. Otherwise we analyze its risks. This should result in a value that we can use in a decision table to determine whether we want to actually execute the buying and selling of this cycle. We then determine the amount to trade, which should also be a decision table, and we can then buy and sell. And while this buy and sell process is underway, it might find that we have no longer the same exchange rates as we had in the beginning when we found the cycle, so it might not be profitable anymore. So it can throw an error event, which we'll call determine new cycle, and then we repeat the process. And once we're done, we remove the cycle from ongoing cycles, and then we should see that some profit has been made. This process will only happen very rarely, even though it's one of our core processes, because in reality arbitrage cycles are very rare to occur, and for long, and only for short times. We also have another EPA called the price peak EPA, and it looks like this. We use a counting sequence operator to find either a high peak or low peak. Then we send the message to GroupÄØÅ. That should trigger the buy and sell process. And so we can send both an arbitrage cycle to the buy and sell process, or we can send a price peak, and the buy and sell process will then differentiate between the two messages and choose a strategy to exploit either of the messages.
For this part of the project, we'll have a look at the risk analysis process, which here can be seen in the Camunda. We start by getting a risk report generation request, then we determine the risk factors. After that, we determine the risk reward ratio, which sends a post request to the city application, which in turn sends back a response with either high risk or low risk. If high risk, we terminate the process with a negative result, since no one is interested in investing money in a high risk situation, given our project. If low risk, we continue on to check the popularity on Twitter. And this is done in the same way by posting to city and getting a response back. If not popular, we again conclude the process with a negative result. Else, if popular, we continue on to make an overall assessment, and then again, if it's assessed to be a high risk opportunity, we again terminate with a negative results. If low risk, we then continue on to generate the risk report and then send the positive risk analysis back to the super process. In city, we have the following stream: risk analysis, which listens on port 8180, add risk analysis, which takes step and instance ID as input. Step is used to differentiate between the different steps given in the process, which is risk reward ratio, Twitter, and overall assessment. And the instance ID is to differentiate between the different processes. Given the input from the risk analysis, the following JavaScript is executed and will give a response back to whether or not, given an example, if this step is tweet, it will give a response whether or not it's popular or not popular. And this is randomized, sort of randomized, by given that if it's larger than 0.75, it will be considered popular. Same for risk reward, which is set at 0.45, since at a real scenario the risk would be considered very high if it's 0.45, and then the overall assessment would be a random generated response. The response is then posted back with this risk response stream, which sends it back as a message, which we can see here is received as messages. And then if we start a couple of processes, we can see that this is the path that the process is likely to take, so most of them will be taken by the high risk and then negative outcome, since it's it's 55% chance to land here. And then for the Twitter, we have to be more than 0.75 for the path to go up here, and then we have a 50-50 split for going up here and then all down here. So only 7 of the following processes has given a positive outcome. The reason for our analysis of Twitter and risk reward, as well as assessment, to be random is that, as mentioned in the report, Twitter API can't be used freely now, since you have to register and tell them what you want to do with the API before they even consider letting you do it. And the risk-reward ratio is done on a complex historical analysis of the stocks, which we feel is beyond the scope of this project. So we'll just simulate it with a pseudo-random generation. And the assessment is, again, something you can't do without thorough checks of the former parameters, and since they are random, this will be random as well.
Right, so to briefly introduce the way this presentation is going to be structured, we have in the top left corner a bash client that will basically run the Node.js application. Then we have in the bottom left corner the Camunda cockpit that will present the process and the deployment and the process instances. And finally, on the right side, we have the source code in terms of the Node.js application, basically application that is being run from the top left corner. Right, so in this presentation I will tell about the buy and sell process in relation to the arbitrage opportunity. So basically how this works is that I have the process in Camunda modeler, which I will deploy. So we are then able to see the process in Camunda, and we can see that yeah, it is here. So in order to run this, I've made some Node.js application that can take care of all the service tasks in the process. So we can try to run this by first running the Node.js application as seen in the top left corner. So what this does is that it subscribes to all the topics that the service tasks exposes, and it is basically polling in order to sort of indicate that it is active. Then we can use Postman in order to give some information to Node.js about the process and the execution. So basically what this does is that we throw this JSON against the REST API for the Camunda, and this will basically start a process instance given the JSON elements. Here you can see in the top left corner that the process is being run. I've made console logs in order to sort of follow the process and see how it goes, and what phases it goes through in terms of the process, what activities, and you can finally see it ended. So now we can stop the Camunda or the Node.js and see what's actually going on. So when looking from the top, you can see that it basically goes through the individual activities that can also be seen in the BPMN model in the bottom left. So in the bottom left we have different tasks or different activities, some of them which are service tasks. So here you can see, for instance, check currency if it's already purchased. This can be followed in the Node.js prints or console logs. So here we have the check if the currency is already purchased. Second, we determine the opportunity type, if it's a short-term opportunity or long-term opportunity. This is specified in the JSON that is delivered in the beginning. Here we have the short-term opportunity. It will show the opportunity type in the actual console logs in the Node.js application. Next, it will go up here and into the initiate cycle service task, which is displayed here. When this task is completed, we go into the actual cycle, which runs in a loop, as you can see. So here we have, first of all, the check if exchange opportunity is valid. This is done by this. We have a console log that is saying validating opportunity in cycle. We have the cycle number, and we have the rate in which we will want to determine if we will still go on with the specific cycle. So in Postman, we give the rate threshold, which basically comes from the previous process about the arbitrage cycle or the arbitrage opportunity itself. If the threshold is met or is greater than in this instance, then we will still run the individual cycles. So as we can see, the actual rate from the crypto compare API is 78.55, and we have set the threshold to be 70, which means the cycle will run basically. So here we run through the individual service tasks as seen in the BPMN model. Considering the fact that the opportunity is still valid, we'll go through the exclusive gate and go into the trade for target currency. This can be seen here. Basically, we have all the different service tasks that we will go through. This is just indicated by a console log for all of them. Finally, when those are done, it will loop in order to check if the opportunity is still valid again. If it is still valid and the rate is checked in order to uphold the threshold, then it will proceed in a loop until the threshold or until the actual rate is maybe below the threshold and we cannot exploit the rates anymore. So then it will basically save information about opportunity intent and check if it's the first cycle. If it's the first cycle, it will throw an error in which the previous process will handle, considering the fact that this is a sub-process to that process. And then if it's not the first cycle, it will basically exit the sub-process run arbitrage cycle. It will then sell the cryptocurrency and notify about the completed opportunity. For the other part, we have the long-term opportunity that will notify about the purchase, determine a sell opportunity. It could be discussed as this could be a sub-process of the crypto analyzer, as seen in the swim lane. Then we inform about the sell opportunity and actually sell the cryptocurrency when it's the good time to do so. Finally, it meets again and notifies about the completed opportunity, which will then display in a dashboard. To get an idea of how the code works, we have this index.js, which is basically a Node.js application. Here we have a few constants that is from the Camunda external task client.js, which is basically a Node module to Node.js that can take care of all the external tasks and the subscriptions and these things. So here we also use the GroupAØÅ API in order to fetch real-time data, and we have a API key for this GroupAØÅ in order to get it to work. So basically how it works is that we specify the base URL for Camunda, specify a client, given the configuration from that basically specifies the base URL. Then we subscribe to all of the service tasks as seen in the BPMN model over here. Basically how this works is that we subscribe to all of them. When their respective topic is called, when they basically land on the activity, the topic will be called, and the Node.js application will be able to fetch this call. So the most exciting subscription would probably be the validate opportunity, which is seen in the BPMN model up here. Here we check if the exchange opportunity is still valid. So this works in such a way that we first of all log if it's still valid. We're basically validating here. We specify some variables that we want to sort of proceed to have when we complete the task service. Here we get some information about the cycle number, and finally we have an if statement that says if the cycle number is above the cycle number before cell, which we specify inside the postman, cycle number before cell. Then if we are still below this number, we will set the cycle number to basically cycle number +1 because we visit the activity again, and then we will make a basic console log. If it's above, we invalidate the opportunity attempt and say that it's no longer valid and we would want to end the cycle basically. But for the second part, we've also made a brief call to the GroupAØÅ API. Here we get the price from a source coin and a target coin. In the postman example we have here, we have Bitcoin as a source coin and Litecoin as a target coin. And here we specify the exchange, example exchange in this instance, to be a specific exchange. We then take the price, define a price constant, and take the first value in the price, because it will only return one price, which would basically be the rate from source coin to target coin. We then have, if the price constant, or if the price is above the rate threshold, then we accept the exchange. We write a console log and say it is above and that we can still run the cycle. If it's below, then it must mean that the cycle is no longer valid, and we invalidate it and set the end cycle to true. And finally we can complete the task service. And this will basically end the validate opportunity. Otherwise it has mostly been about trying to write where we are in terms of the activities, but these should all in a real life scenario have their respective functionality that should take care of the individual activities. In this instance it's mostly about writing what has happened in the given activity and then completing them so that the cycle can can continue and the process itself can continue.
This is the process report performance to investors, and we wish to import this process into Camunda. We do this by making a simple post request like this and importing the diagram as form data and just click send. Now if we go into Camunda cockpit, we should be able to see the new process here. Now we want to actually run all the different tasks in the diagram, and we do this with a Node.js, a JavaScript module. We use Camunda external task client JS, and in here we simply subscribe to all the different tasks there is, like prepare report, calculate risk, save calculations, evaluate performance, ship and send. Now an interesting task to complete is this calculate risk, because here we make use of an API we've made. This API is a simulation of the popularity of hashtags on Twitter, so it simply returns what tag you made, the popularity rating, and how many times this hashtag was used on Twitter. Now this simple Python script can be called from Postman, for example. So if I wanted to get the popularity rating of Bitcoin, I would just simply make a GET request like this, and we would get back this JSON data. Now if this if uses of this hashtag is greater than 300, we don't see this investment as a risk, but if it is used less than 300, we see this investment as a risk, and so we prompt the user accordingly. And if for some reason our current risk, the one we just calculate, is different from the expected risk, we also let the user know. Now let's actually run this Node.js application. So when we run it, it simply subscribes to all the different topics there is in the process, and it is polling for some tasks. And if we try to start this process and complete it, we use a simple post request process definition key and then the name of the process and then start. And in the body we have some JSON, which simply is a definition of what variable the investment type should be, and in this case it's arbitrage. Now if we try and send this, we should see some tasks being completed and a result of the risk. And as we see, the completed one task here, and we completed another task here where we calculated the risk, and we can see that our estimation of the risk was incorrect because we assumed that the risk was a risk asset, but the use of the hashtag was over 400, so therefore the risk was not a risk asset. Now if we try to run this process without using our Node.js application, we simply, like before, send a post request with these variable settings. And if we take a look in Camunda, we should see a process instance here, and we can see that we're waiting for an external task here to complete, and this is exactly what our Node.js application takes care of.